Throughout its producing life, a well requires various maintenance and repair operations to improve or maintain production. In this lesson, we'll look at some common challenges encountered during production and the well servicing and workover methods used to address them. We'll also discuss the types of equipment used in these operations. Well servicing generally refers to more routine maintenance work performed on a well while production continues. In contrast, a workover is a more extensive repair or maintenance procedure that requires shutting in the well or stopping production before the work is performed. A workover can also include changing the producing zone in a well or recompleting the well to produce from a different pay zone. Common servicing issues an operator may encounter that limit production include corrosion, scale, paraffin, sand, and part failure. And let's begin with corrosion. Reservoir fluids include water. This water causes corrosion to be a pervasive issue during production. Corrosion is the deterioration of the tubing, casing, and wellhead, with rust being a common example. Chemicals are commonly used to prevent corrosion. A liquid inhibitor can be injected into the well using a chemical injection pump. Alternatively, a solid inhibitor, referred to as a stick, can be dropped into the well. As the stick dissolves, the corrosion inhibitor mixes with the reservoir fluids as they travel up the wellbore, protecting the equipment. Plastic coatings can be used to protect the surface pipes and tanks from corrosion. Some oilfield equipment is made from steel alloys as they naturally resist corrosion. Some types of corrosion are aggravated by oxygen in the air present in the production system. Repairing leaks and maintaining a high fluid level in the tanks can help keep air out. Yet another way to fight corrosion is cathodic protection. When any pipe is placed in the ground, weak electric currents flowing between the pipe and the soil cause corrosion. Cathodic protection involves placing a bar of metal near the buried pipe. Magnesium can be used to act like an anode inside a battery. This reverses the flow of electricity, and the magnesium, as the sacrificial anode, slowly corrodes instead of the pipe. Scale occurs when mineral deposits come out of the water and stick to any surface the water contacts. Common oilfield scales include calcite, barite, and gypsum. Multiple scales can mix and occur simultaneously. Scale can occur within the reservoir, the wellbore, or the production facilities, and causes production challenges. For example, scale buildup in pipes can restrict or even stop the flow of reservoir fluids. Scale inside a heater reduces its efficiency because the scale can act as an insulator between the heat sources and the piping that holds the fluids. Scale can sometimes be prevented or removed with inhibitor chemicals. In more severe cases, scale has to be scraped or sandblasted away with the operation shut down. Paraffin is a waxy substance deposited by crude oil as it flows up the wellbore and through the surface equipment. Paraffin occurs in the reservoir as a liquid, but as oil flows to the surface and cools, the paraffin turns solid. Similar to scale, paraffin buildup slows or blocks the flow of reservoir fluids. In some cases, injecting hot oil or steam into the tubing can melt the paraffin. A solvent can also be used to dissolve paraffin, or it may be scraped away. Sandstone reservoirs often have severe problems because formation sand is produced along with the reservoir fluids. Sand production erodes equipment and can compromise the well's integrity. Downhole slotted liners or screens are often used to control sand production. These devices function as a filter within the wellbore, but can become clogged. A more common technique is gravel packing, which utilizes a screen along with graded gravel The gravel does the work of holding back the sand, protecting the screen, but allows the reservoir fluids to flow to the surface. Another approach in controlling sand is to pump a plastic resin into the formation. The resin hardens and bonds the sand grains together to prevent them from entering the wellbore. However, this technique can lower the permeability of the reservoir, which reduces the flow rate of the reservoir fluids. As we saw in our drilling and prior production lessons, every well contains many sophisticated pieces of equipment. Equipment can fail and require replacement at some point during the well's producing life. In this case, the well must be shut in and a worker operation is undertaken. For example, rod pumps and sucker rods fail because they are highly stressed by repeated cycling. Tubing and packers are also commonly replaced due to the downhole flow rate, pressure, and temperature stresses put on them during production. Many of the servicing examples previously discussed, corrosion, scale, and paraffin, can accelerate the need for replacement of this equipment. Now that you understand the common servicing challenges encountered during production, let's look at some of the equipment used in both servicing and workovers. Well servicing and workovers are often performed using workover rigs, coiled tubing units, or wireline units. A workover rig is basically a scaled-down drilling rig. Once the well is shut in and its pressure is under control, the workover rig can remove and replace the sucker rods, downhole pump, or the corroded production tubing from the well. The workover rig can also be used to insert cleaned out and repair devices into the tubing or casing. A coiled tubing unit allows the operator to enter the well without removing the production tubing. This type of unit uses a reel of flexible tubing supported by a crane. The coiled tubing, an appropriate tool, is inserted into the well to perform the remedial activities. A wireline unit consists of strong, thin wire mounted on a reel at the surface of the well. The wire is then used to lower tools or measuring devices into the well.